Hello. In this presentation, we are going to give the explanation of our project Microwave Oven. So the team members are Ramesh, Rohit, Pallavi and I myself, Janvi. First, we will start by explaining the overview of the project. In this project, first I'll be explaining about the introduction to C, then embedded systems, then microprocessor and microcontroller, and then tools used for the project, and at the end components for the PIC 16F877A. The main goal of the project is the working of the microwave oven. Introduction to C. C is a general purpose procedural high level programming language which is used in the development of computer software and applications, system programming, games, web development and more. C was developed by Dennis Emertxe at the Bell Telephone Laboratories in 1972. It is a very powerful and flexible language which was first developed for the programming of the Unix operating system. C is one of the most widely used programming language. C programming language is known for its simplicity as well as efficiency. It is best choice to start with programming as it gives you a foundational understanding of the programming. Now, I will explain about the variables. Variables are basically the names of a memory location which stores some data. The example can be integer x. Here x is a variable which is of type integer. Now, variables have some rules while writing. Variables are case sensitive. The first character should be either alphabet or underscore. Then there should be no comma or blank space. And we cannot use any symbol other than underscore. Now, what are the constants? The values that do not change are called as constants. There are three types of constant: integer constants, real constants and character constants. Integer constant basically includes the natural number, whole number with positive as well as negative signs. Example 1, 2, minus 1, minus 2. Then real constants, they are the real numbers, minus 1.4 or 3.14, etc. Character constant basically include alphabets as well as symbols like A, B, hashtag, etc. What are keywords? The reserved words that have special meaning to the compiler are called keywords. Example else, long, double, extern, char, used for character, etc. So here we are showing a basic structure of a C program. Very basic. What we first mention is the hash include stdio.h which defines standard input output and dot header file. Integer main, it shows the main steps of the program, like printf is used to show the output, what actually will come on the output screen. Like here we have mentioned hello world. So when you will execute this program, in your screen you will get hello world. Printf is for output and return 0 signifies that there are 0 errors. What are instructions? There are statements in a program. These statements are called instructions. So, it is of three types: declaration instruction, type declaration instruction, then arithmetic instructions, and then control instructions. Type declaration instruction declares the variable before using it. For example, integer a is 22. Here we are using an integer type data, that is a variable whose value is 22. Then arithmetic instruction basically includes the operator and the operands. Here a plus b is an example where a and b are operands and plus is the operator. Now third is control instruction. Control instruction have four types. They are sequence control, decision control, loop control, case control. Here I have given an example of if statement where I am mentioning if I modulus 2 double equals to 0, printf even. That means we will get the value even if the number is divisible by 2. Now, what are conditional statements? They are of two types, if else and switch. So, if else has the syntax type like this. First we will write if, then condition, then whatever is true, do something which is true. Else, if the condition is not true, then we will write the else statement. After that we have else if. Here first we will write if, then its condition, and if the condition is true, we will write that true statement. Now the difference in else if and if else is that here we have second condition as well. There we were using the false statement only if the first condition was not true, but here we have more than one condition. So else if condition 2, then if that condition is true, we will give another statement. After this, here comes conditional operators, ternary condition. In this, the syntax is like this: condition is written, then question mark, then if the condition is true, the true statement, colon, the false statement. Okay, for example, the condition is A is greater than B. Then statement 1 will be executed. If A is not greater than B, statement 2 will be, the false statement will be executed. Then we have switch conditional operator. Here we have different cases. Whichever is true, that statement will be executed, and if none of them are true, we will give some default statement. Then that default statement will be executed. The switch properties are cases can be in any order and nested switch can be used. That means switch inside a switch can be used. After this, loop control instructions. Loop control instructions are used when we need to repeat some parts of the program. It is of three types: for, while and do while. So here is the syntax of for loop and its example. In for loop, we will first initialize, then we will write the condition and then the updation, and then we will do the program, whatever we have to define in our program. So here is the example. I have initialized inside for some integer variable gfg whose initial value is 1. Then the condition it should be less than or equal to 5, and then it is incremented by 1. So in my statement, printf statement, it is emertxe \n. \n means the next statement should come on the next line. So here it will execute from 1 to 5. When it will reach above 5, it will come out of the loop. So emertxe is coming for 5 times. Now we have the example and syntax of while loop. So while loop syntax is like this. First we will write while, then condition, then curly bracket, and then we will define the program and curly bracket close. Here the example is like this. We initialize some integer type I variable whose value is 0, then while condition I should be less than 5. That means we will print emertxe from 0 to 4. After that it will come out of the loop. That's why emertxe is here for 5 times. Now do while loop. So while loop is an entry control loop. We first check the condition, okay, then only it got executed. Here the do while loop will act as an exit control loop. Okay, first we will see the statement. After we will print, we will check the condition. That's why in this we have written do, then do the something, then after this at the end we have written while condition and semicolon to end statement. The example is like this. Integer I is equals to 0. It will start from 0. We need to print emertxe and we will update I++, and at the end we will check I is less than 3. So it will print from 0 to 2, 0, 1, 2. As when I will reach above the value of 3 or 3, then it will come out of the loop. That's why emertxe is printing here for 3 times. When I value is 0, then emertxe will print. When I will increment by 1, I equals to 1, emerge Z, then I equals to 2, emerge Z. Now we will talk about continue statement. Continue statement is used to skip to next iteration. Okay. Here you can see in my program, first I have initialized an integer I equals to 1, it should be less than equals to 8, then I plus plus. If I double equals to 4, continue printf percentage d comma I. So what continue statement will do now? It will print the value of I till the when I is equals to 3. Okay. As soon as it will be equal to 4, it will skip that value and it will move to I equal to 5. That's why here, while I is less than 8, it will print till I is less than 8, I plus plus. That's why our output is like this: 1, 2, 3. It skipped the value 4, then 5, 6, 7, 8. Okay, and in this way we are getting the output. So now we will learn about the example break statement. Break statement is used to exit the loop. So what it do, right? It is totally opposite of continue statement. As soon as you will write break, it will come out of the loop after that condition. For example, here I have initialized data value I equals to 1. It will execute till I is less than 5, I plus plus. If I double equals to 3, it will come out of the loop. So it will execute for z1, 2, and when it will reach the value 3, it will come. This is if value, else percentage d comma I. So if it is not equals to 3, then it will print the value. So here is the output: break in for loop 1, then 2, break in while loop, break in for loop 1, 2, and then break in while loop 1, 2. Using break inside while loop to terminate after 2. So this is how we are getting this output. Because teacher I is 1, while I is less than 20, it will give the condition of if I is double equals to 3, it will break. As soon as it will reach 3, it will come out of the loop, else it will print the value and then I will get incremented. That's why we are getting this out. Break in for loop 1, 2, and when it reached 3, it came out of the loop. So that's all about the C part.
Hello everyone, I am Pallavi. As Janvi already told that we'll be working on microwave oven as our project, it is important to know what is embedded system, as microwave oven is an embedded system. So the embedded system, it is a combination of hardware and software which is used to do specific tasks. Example, washing machine, television, telephone, fridge, etc. The washing machine does only the operation of rinse and wash. It can't do the operation which can be done in microwave oven. So this is the basic block diagram of an embedded system where it has input devices, processor, program memory, data memory, timers which are used to produce some delay, serial communication ports and parallel ports for the communication, interrupts and output circuits. So any embedded system to be efficient, it is very much required to be reliable. That is, the performance should be very high um, and it should be cost effective. It should be less cost and the power consumption should be very low. And the processor power and the memory usage should be very efficient. So this is the common design matrix of an embedded system, that is time to prototype, the power, performance and correctness, size, maintainability and flexibility, safety, unit cost, and time to market. Real-time system. So a real-time system means the system is subjected to be real-time. The response should be guaranteed within the specific time constraint, or the system should meet the specific deadline. Is called real-time system. The real-time system are again into three types: hard real-time, firm real-time, and soft real-time. Hard real-time, it should meet the deadline no matter what. Like it is used in the life critical applications like airbags in the car and pacemaker in human body. Firm real-time, it is similar to the hard real-time properties like autopilot and spacecraft. Soft real-time systems have tolerance in meeting its deadline, like personal computers, audio and video systems, and key toy. Microcontroller. So in our project of microwave oven, we'll be using microcontroller, which is PIC microcontroller. So what is microcontroller? It is an integrated circuit, that is IC, which is capable of being programmed to perform a specific task. And also have few restrictions like memory size, IO capabilities, and peripheral functions. This is the difference between microprocessor and microcontroller. In a microcontroller, the timer, CPU, RAM, input output, ROM, serial interface are all connected on chip, a single chip. Whereas for a microprocessor, the timer's input output, RAM, ROM are externally connected. This is the basic difference between microprocessor and controller. So our project is microwave oven. Uh, to implement it, it is important to know these terms: host, target, and cross compiler. So host, the system which is used to develop the target, is called as host, and the system which is being developed for specific application is called target. Cross compiler, it is the application which is used to generate the code for another architecture being actually present in another architecture is called as cross compiler. So the tools which we use for our project microwave oven are this: MPLab X IDE, XC8 compiler, and PICSimlab simulator, where XC8 compiler is a cross compiler. In PICSimlab simulator, we will be seeing about the PIC16F877A microcontroller.
Hello everyone, I am Rohit and I am going to explain about this microcontroller PIC16F877A. Coming to its architecture, it has various devices connected to it. First is the GPIO, which is the general purpose input output used for interfacing various devices. Next is the I2C, RTC or EEPROM. EEPROM is a memory, I2C is stands for inter-integrated circuit. It's a bus interface connection protocol incorporated into devices for serial communication. Then we have LM35 temperature sensor, which is basically a temperature sensor. Then ADC, which is analog to digital converter, which converts the external inputs external inputs to digital so that the microcontroller can convert it. And the arrows, if the arrow is going towards the microcontroller, then it is the input. If it is coming out of it, it's an output. And if it is both the arrows are there, then it is bidirectional. RS-232 is a recommended standard in a standard originally introduced in 1960 for serial communication transmission of data. It formally defines signals connecting between DTE, data terminal equipment such as computer terminal, and DCE, data circuit terminating equipment for data communication equipment such as modem. LED. LED is a simple output device which produces light using electricity. And buzzer, which is also an output device which produces a beep sound. Then we have digital keypad and matrix keypad, which both are keypads. Digital keypad only serves as input, matrix keypad is bidirectional. SSD is a memory, solid state drive. Then CLCD, character liquid crystal display, which is the only display available on the microcontroller. We can use this to display anything we want. This is basically the PICSimlab. And coming to the components of PIC16F877A microcontroller, It has LEDs, digital keypad, interrupts, timers, clock inputs, SSDs, CLCD, matrix keypad, analog inputs. And coming to LED. LED is an external device connected to microcontroller port. A port is interface between the controller and external peripheral. Based on the controller architecture, you will have n number of ports. The target controller is PIC Genius board is PIC16F877A from Microchip. The next question arises is, how do I know how many ports my target controller has from microcontroller architecture, which will be detailed in the datasheet provided by the maker. By reading the datasheet, you will come to know that there are 5 ports. Again, a question where the LED is connected. You need a schematic of the target board to know this. A schematic is a document which provides information about physical connections on the hardware. From the schematic, we come to know that the LEDs are connected to port B and port D. Port B and port D. Port is a peripheral, and we need to know how many access and address. This info will be available in the data sheet in port B, port D and data memory sections. So as I told, this is basically the circuit on board schematic. Then coming to digital keypad circuit on, this is also a schematic. So digital keypad provides simple and cheap interface, comes in different shapes and size, preferable if the number of user inputs is less, mostly based on tactile switches. Some common applications of tactile keys are HMI, mobile phones, computer mouse, etc. And interrupts. An interrupt is a communication process set up in microprocessor or microcontroller in which an internal or external device requests the MPU to stop the processing. The MPU acknowledges the request, attends to the request, goes back to processing where it was interrupted. There are 2 types of interrupts, commonly hardware software, but here we have hardware, software. In hardware we have non-maskable and maskable. Non-maskable are the most important interrupts, time critical interrupts, etc. Maskable interrupts can be covered for some time, it can be delayed, etc. Then even maskable interrupts have external and internal interrupts. Coming to CLCD, which is character liquid crystal display, most commonly used to display ASCII characters. Some customization in symbol possible. Communication modes are 8-bit mode and 4-bit mode. And this is the schematic of the CLCD. So yeah, that's all it is.
Hello everyone, myself Emertxe. Now I gonna visualize how our application microwave oven is gonna work. For that application, this is a code which has been written. So now we gonna build the code. As you can see, the code has been successfully built. So after building the code, it will create an X file which we gonna upload it to our PICSIM lab to visualize the application of microwave oven. So this is a PICSIM lab board. So we are using PIC Genius PIC16F877A. So we're gonna load the X file which we previously created. So this is the X file, we're gonna load it now. So we are using 16:4 display, and you can see like on the display powering on microwave oven. So these are the matrix keypad. These are the LEDs, and buzzer we can manually turn it off and on. And this is reset. If you press it, entire microcontroller gets resetted. So these are the 4 cooking options. So let's go for the first one. So the total power is 900 watt. So let's take for example as 15 seconds. So star is for clearing, and hash is to start. So the cooler has started rotating, as you can see. So 4 is used to resume, and 5 is used to pause, and 6 is used to stop. Okay, so we'll resume it now. So let's wait for 28 seconds. After the 23 seconds, after the timer has been completed this count, the buzzer will turn on indicating the user. As you can hear the buzzer sound. So let's go for the second option, which is grill. So it's a similar scenario of previous get but for different option. So let's consider the same time 15 #6. So it has started, cooler has started rotating, and you will hear the buzzer sound now. So let's go to the third option. It's like we are setting the temperature of the microwave oven, that is preheating temperature. So we can set it up to 180 degrees Celsius. So we'll set it for 25 degrees Celsius for example purpose. So let's enter it. So this is preheating, like the oven is preheated with 25 degrees Celsius. So after this preheating, it will ask us to set the timer for operations like grill or micro, etc. So see now it's asking us to set the timer. So let's set it 15. Start. So coming on to the fourth option, start. This is a default mode where the timer starts from 30 seconds, which is default timings. That's it everyone, this is our microwave oven project which has been built in PixSim Lab. Thank you.